All right, then we're going to our second presentation, and it's going to be by Aaron Baker. His presentation topic is Interrupting the Bachelorette, a statistical analysis of tornado warning in East Texas. And he is from Department of Mathematics and Statistics, and his advisor is Jacob Turner, Dr. Jacob Turner.
We're trying to get all Zoom over here. Can y'all hear me okay?
Yes, yes.
Okay.
A little bit, if you could make it a little bit.
How about now?
Yeah, that's
Okay,
better.
cool.
Much better.
All right, let's see. I can get this shared. And all right, so hopefully I am sharing the right thing over here. And so yeah, my name is Aaron Baker. Current grad student here at SFA and in math. And today we're going to talk about interrupting Bachelorette and go over some statistical analysis of tornado warnings here in East Texas. So kind of the backstory for this project was back over the summer, there was a viral video that went out, and it was meteorologist Jamie Simpson from, he's the one of the meteorologists at the Fox affiliate over in Dayton, Ohio. And he started, tornado warnings were out for his viewing area. So he went on the air to kind of point out, like, hey, here's the tornado, go get your safe spot. But not long after that, he started on the air. A lot of people on social media, especially Twitter, started tweeting out were mad because they were interrupting their favorite program, and much less they would rather watch the Bachelorette over him. And so he ended up getting kind of fed up with all that and ended up calling out the viewers, saying basically for not taking the situation seriously and basically not caring about the other people who were in the path of this potential tornado. But unfortunately, this isn't just in one area that happens. It happens across the country, and it definitely happens here in our East Texas television market. And so I started thinking not long after was our television market that Nacogdoches in East Texas is in covers 26 different counties, and it's a pretty big area. So how does, on top of the National Weather Service kind of improving the tornado warnings, how has that happened? Has it changed any effect of any tornadoes that the percentage of tornadoes that do produce these warnings do produce tornadoes over the ones that don't? So basically what a tornado warning is, these are issued for storms based from the National Weather Service office. Originally, when they started doing this, they were giving it out by the county. So these type of warnings were great for these smaller counties in East Texas, like Cass County. But like, for instance, if the storm was only clipping a small part of the northern part of the county, people in the south, or these larger counties, people in the southern part of these counties, they might not be getting the storm at all. It might just be blue skies. So they wouldn't necessarily need to take cover and take their tornado precautions. So National Weather Service went to the drawing board, and in October 1st, 2007, they issued what's called storm-based warnings. And basically what these are, they're basically little polygons around the storm, and only the people in this polygon are the ones that definitely need to take their tornado precautions and so forth. So to kind of give an example here, you see here on the left, we have, this is actually one big tornado warning, and it's for Cherokee, Rusk, and Nacogdoches County. I'm pretty sure this is the tornado area they're looking at. So it probably, especially for Nacogdoches County here, it's probably just going to clip this extreme northern part of it. So the people, like especially in the city of Nacogdoches, they didn't really need to take cover because the tornado was nowhere near them. Whereas we have this tornado warning on the storm-based warning, we see that it takes a small part of Cherokee County, a very small part of Nacogdoches County, as well as Shelby, Panola, and Rusk counties. And you see that based on the way this polygon is drawn, the tornado is probably moving this way, and only these people really need to worry and get into their shelters and so on. And people the people here in Nacogdoches didn't have to do anything at all. So all these weather warnings that are issued, it doesn't matter if it's tornado, severe thunderstorm, flash flood, no matter what, they are archived for data research purposes like this one. And so I went into the IEM, or the Iowa Environmental Mesonet Severe Weather Database, and basically went through each 26 counties and pulled all the tornado warnings from this. And likewise, all the confirmed tornado paths, they're archived through the Storm Prediction Center in Norman, Oklahoma. And so they go out, and so we had 2 separate files, and I really had to go in through each county warning, each tornado path, and confirm whether or not these storms had a tornado or not, these warnings. And to make matters difficult, these are the 26 counties that are the ones that are colored are the 26 counties in the Tyler, Longview, Nacogdoches television market. And so the 2 counties in red, Houston and Trinity, they're actually given out. Their warnings are given out by the Houston forecast office. The green counties, Anderson, Henderson, Van Zant, Rains, and Hopkins, their warnings actually come from the Fort Worth National Weather Service office. And then the other counties in purple, they actually come from the Shreveport office. So that even made it more fun to go out and try to track down these warnings, because I had to go down to each forecast office, then down to each county. And so when I was going through each warning and trying to compare it to where we had a tornado or not, I used 2 different types of verification for this. So the National Weather Service, when they're doing their stats, they'll actually go by how the warning polygon intersects the counties. So for instance, if the warning intersected 3 counties, but the tornado path only went through 2, that's considered 2 yes confirmed and 1 no did not confirm. And another way that I went through it, I went through each individual polygon and decided, okay, did the tornado path intersect this polygon at all, no matter what county? And if it did, that was a yes. If not, that was a no. So to kind of iterate on this is a tornado warning here for Cherokee, Nac, and Angelina counties. And the tornado path right here goes between Angelina and Cherokee counties. So if we were using the NWS version, this would be 2 yeses, 1 no. But if we do it the unique way, it would just be 1 yes, because this is just 1 warning. So looking at the results from the unique tornado warnings, we kind of, when the data is all spread out by year, it went from 2000 to 2018. And we kind of see this is about where they started. This is all county-based warnings, and these are all basically the storm-based warnings. And you kind of see there's a lot more storm-based warnings because they're just these individual polygons that keep, if it needs to go downstream, they'll keep going with it. So when we look at the data, 30 of these county-based warnings had a confirmed tornado, where 55 did not. And with the storm-based warnings, 86 had confirmed tornadoes and 370 did not. 370 tornado warnings did not produce a tornado at all. And so when we look at proportion testing, where we're testing proportions of warnings with the confirmed tornadoes and the county-based compared to the storm-based, we see that 19% of these confirmed tornadoes are within the storm-based, and 35 of the confirmed tornadoes are in the county-based. So it's not really looking too good so far for the storm-based warnings. However, when we look at the overall warnings, doesn't matter the type, we see that 21% of these warnings actually did produce a tornado. The rest did not. So when we look at the odds ratio testing, we see that when we're given a tornado warning, and we're giving a tornado warning that did produce a tornado, we see that the odds of it being a county-based warning compared to a storm-based warning is about 2.3. And then when we look at it overall, comparing did it produce a tornado or not, we see that if we're given a tornado warning, the chance that, or the odds that it did not produce a tornado is about 2.7 times compared to ones that did produce a tornado. So maybe the NWS is, so unique didn't quite help my case here, but let's see what the NWS had. When we look at the NWS verification type, we see that we get basically the same distribution, where we got minimal up until 2007, 2008 onward, we have a bunch. And so of that, 33 confirmed tornadoes did produce from the county-based warning and 73 did not. And then we have 145 storm-based warnings that did produce a tornado and 755 that did not produce a tornado. So again, looking at these proportions here, we see that 16% of the confirmed tornadoes within the storm-based warnings occurred, and then 31% of the confirmed tornadoes, or 31% of the county-based warnings did have confirmed tornadoes in them. Then when you look at the overall, again, we still see that it's still less than half, with 18% of these warnings producing a tornado and the rest did not. So from the odds ratio testing standpoint, we see that the county-based warning produces a tornado about the odds of that happening is about 2.4 times compared to the storm-based warnings. And then when we look at overall, again, it's the tornado not occurring. So basically, if you're given a warning, the odds that it doesn't produce a tornado is 3.7 times compared to the warnings that do produce a tornado. So it definitely does not look good. So in conclusion, this new warning standard so far has not been very effective, since the number of warnings that do not produce a tornado is definitely higher. And these odds of the tornado warning not producing a tornado could be up to 4 times compared to a warning that does produce one. So it's kind of some future work that we still want to do with this project is, so when you have your radar, because of the curvature of Earth, the further away you are, the higher the beam in the atmosphere. So does this have any correlation with it? So like with these false positives, do you have more false positives the further away, and does it diminish as you get closer? And we also want to look at, there are confirmed tornadoes that were not even tornado warned at all. So we just kind of want to go through and see if there's any, what the ratio is with that, how many have they missed with the tornado warning, and so forth. And with that, I'll take any questions, and I thank you all for your attention.
Thank you, and thank you for staying on time. Very interesting. Now I have a basis like why I don't worry about those warnings, because I can see it's a lot false of them. So any questions? Comments?
This is Andra. I would just like to thank Aaron for all of his work in this. He's my colleague here in CTNL, and he is an awesome guy that we have weather in common, so we always talk about it. Thank you, Aaron, for the presentation. It was very good.
Thank you.
Thank you. Thank you for the comment. Any other comments?
I have a question, actually.
Sure.
Are there methods to improving warnings?
They're trying with it. I know the initiative really got started back, there was a big super outbreak in April 27, 2011. And I think they had 62 tornadoes that hit the state of Alabama. And so because of that, they thought the death toll with that especially was would be like 30 to 50, but ended up being well over 200. So the Birmingham, Alabama office has actually been working with a bunch of social scientists trying to figure out how can we improve these warnings, how can we look at the science from it, but also get the people's perspective, so we can try to get this false alarm ratio down and get people to take these warnings seriously. So that has been going on for the last few years.
Okay, thank you.
I'm Rosemary. I'm Sarah's sister. I appreciate your work too. Our anecdotal response to the warnings is we run and look at the weather radar and determine for ourselves, are we in the path?
Yeah.
But that is a issue that needs to be solved. I'm glad you're looking at it to get public
Aaron, I have a
confidence
question.
in the warnings.
Yeah.
Thank you.
Thank you.
Aaron, I have a question as well. Quite interesting. I'm wondering, is there any analysis of which factors contribute to accuracy most in terms of, say, weather stations, weather balloons, and I don't even know what else, but what might have the greatest impact on increasing or decreasing accuracy in an area?
Yeah, so they definitely are trying out especially here in the Southeast, since our tornadoes are much different compared to like what's in Tornado Alley. They kind of call it a Dixie Alley for a second type of one, but there's a huge science project going on called Vortex Southeast. And basically any storms in the Southeast that are likely to produce tornadoes, they're mobile launching these balloons, trying to study the atmosphere to help guide, okay, do we actually need to throw a tornado warning, or can we just keep it as a severe thunderstorm warning per se? But they're looking at that. They are also looking at the radar thing, like I had brought up earlier, because these radars, especially in our market, we got some of these counties that are just on the edge of 2 radars. So it's kind of hard. You're looking super high up in the atmosphere when you need to be low as you can to see these rotations. But yeah, there's been all sorts of projects and stuff going on trying to help get this false alarm ratio down.
Any more questions? A very interesting talk. Well, I guess we're moving to our third presentation.